I'm gonna call me Tutaa. Can you be my Tutaa? I want to feel like Tutaa. Can you be my Tutaa? I want to feel.
Hello everyone, my name is Benjamin and I am your tutor. In today's video, we want to look at what sets are, or rather we want to ask the question, what are sets? So, a set is a collection of well-defined objects. A set is a collection of well-defined objects. What do we mean by well-defined object? Well, the same way a fashion brand is made up of a collection of well-defined clothes is the same way a set is made up of well-defined objects. So, the same way we look at brands like Louis Vuitton, Dolce & Gabbana, Gucci and all these other many brands is the same way we can look at a set. So you can see that this, let's say for example the brand Louis Vuitton, right? It's a brand, right? But in order for this brand to be what it is, it needs to have a collection of clothes. So this collection of clothes is what makes up the brand. In the same way, in order for us to have a set, right, we need to have well-defined objects. And even the clothes themselves are well defined. Whenever you look at something that is owned by Louis Vuitton, you're able to know that's definitely Louis Vuitton. So you can see that the clothes are well defined. In the same way, an object needs to be so well defined that when you look at it, you just say, no, that object belongs to this particular set. So the point that we're just saying here is that a fashion brand cannot exist without having a collection of clothes. In the same way, a set cannot exist without a collection of well-defined objects. See how we're deliberately mentioning the term well-defined. We can now talk about the objects of a set. The objects that make up a set are called elements or members of a set. The same way you are a member of your family is the same way an object can be a member of a particular set. So objects that make up a set are called elements or members of a set. In order for you to belong to your family, there is some relation between you and your family members. In the same way, in order for an object to belong to a set, that object has to have some relation with the other members of the set. Let's add more sauce to this. The same way a group of people needs to be related to belong to the same family is the same way objects or elements needs to be related to belong to the same set. Okay, so the same way you belong to your family and you are related to each member of your family is the same way objects or elements also need to be related to each other in order for them to form a set or to belong to a particular set. Now, we want to find out what is that thing that relates one object to the other. So, the thing that relates one object to another is called a property. A property is also known as a characteristic or attribute. Therefore, those objects or elements that have the same property form a particular set. Whenever we talk about characteristics or attributes, these are things that distinguish one person from the other, right? What features do you have as a person that distinguish you from another person? Or some of your characteristics could be that you have big ears, you have a nose, and people in your family as well also have big ears and nose, so you can tell that, okay, this family is for big ears and big noses, you've seen. So that's the property of the family. Whenever someone sees an individual that has big ears and a big nose, they'll know, this person belongs to such and such a family. Okay, so that's the property. So a property is what relates one object to another object, or that relates one family member to another family member. If two siblings are born from the same mother and father, those two siblings are related by what? By blood. What brings them together, what makes them belong to the same family is blood. So the aspect of blood is what we can refer to as a property when we are looking at family members. Blood can relate two siblings to each other. In the same way, the objects of a set also have particular properties that relate them to each other. And once these objects are related to each other, they end up forming a what? They end up forming a set because they have the same characteristics, they have the same attributes, they have the same properties. So let's look at an example here. The numbers, which are the objects or elements that form the set of prime numbers, all have the property of being divisible by 1 and themselves. Okay? What we're simply saying here is that those numbers that we call prime numbers all have a particular property that relates them to each other. And what is this property? The property is being divisible by 1 and themselves. The property that these numbers have is that they can only be divisible by 1 and themselves. Okay, let's make this example a little bit more practical. Remember that our prime number is defined as a whole number greater than 1 that cannot be divided by another whole number except by 1 and itself. Therefore, what we're saying here is that a prime number is that number whereby if you divide it by any other number other than 1 or itself, you will definitely get a remainder or a decimal number. So let's visualize this, right? On our table here, 2 is being considered as a prime number. So every number that is in an orange box is being considered as a prime number. So let's start by 2. Let's prove that 2 is a prime number. So if we divide 2 by 1, what are we getting? We're going to get 2. Okay, so we can see that no remainder is here and there's no decimal number. If we divide 2 by itself, what do we get? We get 1. There's no remainder and there's no decimal number. But if we attempt to divide 2 by another number, by another whole number, let's say 3, what's going to happen? We are going to get a decimal number. Let's do the calculation. So 3 into 2, we obviously know that that's going to be 0, or it can't, so it's 0. And then we're going to put a decimal point here, and then we're going to add 0 to this number here. So 3 into 20. In this case, we know that 3 goes 6 times into 20, and then the remainder is going to be what? It's going to be 2. So 3 into 2 again, it can't. So if it can't, we add another 0. We have another 20. 3 into 20 again is going to give us 6. So we can see that by dividing 2 by another whole number that is not 1 or itself, we're definitely getting a decimal number. Remember that we said that a prime number is a whole number greater than 1 that cannot be exactly divided by another whole number except by 1 or itself. Alright, so that's the definition of a prime number. So we can see that 2 is definitely a prime number because there's no other whole number other than 1 and 2 that can go into it without leaving a remainder or giving a decimal number. Okay, how about if we try 3? Let's try to prove if 3 is a prime number. So if we divide 3 by 1, we're definitely going to get 3. If we divide 3 by 3 itself, we're going to get what? We're going to get 1. So far we can see that it's giving prime number. Okay, let's divide 3 by another number that is not 1 or itself. So let's try to divide 3 by 2. If we divide 3 by 2, we're going to get 2 into 3 is 1. And then obviously it's going to leave a remainder of what? Of 1. 2 into 1, it can't. So we put a decimal point there and then we add a 0. So it becomes 10. So 2 into 10 goes how many times? 5 times. So we can see that we've divided 3 by another whole number, which is 2 in this case, and it's given us a remainder. So remember that a prime number is a whole number greater than 1 that cannot be exactly divided by another whole number except by 1 and itself. So you've seen in the 2 examples here that when we try to divide 2 here in the first instance by 3, we got a decimal number. And here when we try to divide 3 by 2, we get what? A remainder. So we can see that when we try to divide a prime number by any other whole number that is not 1 or itself, we're definitely going to get a situation where we have a remainder or we have a decimal number. What we have done here is that we've proved that a prime number is that number that has the property of only being divisible by 1 or itself if we are to get a situation where there is no remainder or a decimal number. Therefore, those numbers which are the objects or elements that form the set of prime numbers all have the property of being divisible by 1 and themselves. What relates these numbers to each other in the set of prime numbers is that they all have the property of being divisible by 1 and themselves. I hope this is now clear. With that being said, we've come to the end of today's video. Thank you very much and see you in the next one.
Can you be